We're going to do a really quick review of exponent rules. This is a Math 1 skill. Really, it's a middle school skill, so we're going to go through this really quickly. And they're really important. If you know the exponent rules, then it's going to help you later when we start talking about logarithms. And so that's why I want to review it now. And so the first law or rule is called the product rule. And really simply, all that means is if they have the same base, you add the exponents. And so we'll just jump straight into an example. So if you have a negative 2xy times 3x squared y, well, the stuff with the same base is what we're going to multiply. So my coefficients technically have the same base. It's a constant. It's a number base. So negative 2 times 3 is negative 6. And then my base here of x, they have the same base. So we're going to add the exponents. This x, it doesn't have a number. We know has an exponent of 1. And so same base, we're going to add the exponent. So 1 plus 2 is 3. And then same thing here, this y doesn't have an exponent, but we know there's a 1 there. And so same base y, add exponents, 1 plus 1 is 2. And so really simply, that's what it is. The next one, we'll practice with this one, is basically just distributive property, but we're still using that power rule. And it's basically just multiplication. That's why it's called the product rule. And we're going to distribute this m to the fourth into this term. And so the only thing that it's alike is this base m to the fourth and this m squared. And so when we multiply, we're only going to multiply it by that same base. And so we're going to multiply the coefficient of 1 times 3, which gives you 3. My m is distributed into the other m, so we'll have m to the fourth times m squared, same base, add exponents, m to the sixth, and then nothing combines with n to the third. So that's your product rule. So real short and quick. Law number 2 is the power rule. And so you're going to multiply your powers or your exponents, but keep the base. And so as we progress through, we'll continue to use all the other rules that we have learned or are reviewing. And so this example is 3x to the third y squared times 5x to the fourth. And so we've got multiplication in there, and we've got a power to a power. And so what we want to do is distribute this power into all the other exponents. And so we're going to work this one out. You don't have to rewrite it like this, but I want to make sure you see where it comes from. So we're going to multiply this power 2 to this exponent of 1. So 1 times 2 is 2. X to the third, 3 times 2 is 6. And then that y has an understood 1. 1 times 2 is 2. And it's still multiplied by 5x to the fourth. So your power rule is really just enforcing this first term, and then we use the product rule for the rest to simplify. So the only thing that they have in common is this 3 squared times 5, so that's 9 times 5, which is 45, and this base x. So base x to the 6th times base x to the 4th, same base, add exponents, x to the 10th, y squared. So we'll look at one more example here for this rule, 4x y to the fourth z squared all raised to the third power. We want to distribute that 3 in to all of the exponents. So that's when you have an exponent to an exponent. So we'll have 4 to the third, x to the third, y to the 12th, and z to the 6th. The only thing we can simplify beyond that is that 4 to the third, which is 64. All right, law 3 is the quotient rule. So if you've got division happening and you've got the same base, you subtract the exponents. So first example, 15x to the 8th y to the 3rd divided by 3x to the 4th y to the 5th. And so the only trick with the quotient rule is you want to make sure to subtract where the bigger exponent is. So here when we divide, we've got 15 over 3. 15 divided by 3 is 5. And we're going to keep that where the bigger number is. So since 15 is larger, we're going to keep the 5 on the top of the fraction bar. And then we've got an x to the 8th divided by x to the 4th. So same base, subtract exponents, but where are we going to put that x? Well, since my higher exponent is on the numerator, we're going to leave the x on the numerator. So 8 minus 4 is 4. And then finally, we've got y to the 3rd divided by y to the 5th. So we'll keep color coding. And so my higher exponent is on the denominator. So my y's are going to stay on the denominator. 5 minus 3 is 2. All right, let's combine some of them. So we've got a negative 2 x to the 4th y to the 3rd squared, all divided by negative xy squared times a negative y to the 4th. And like I said, your logarithms aren't going to get this complex, but if you have a really basic understanding of the exponents, when we get to properties of logarithms, it's going to be much easier. So we're going to go ahead and distribute this 2 to all the exponents. So we'll go ahead and do the top. So negative 2 squared. Make sure you're squaring the negative and the 2. X to the 8th, y to the 6th. And we're just following order of operations. So parentheses, exponents first, multiplication or division are interchangeable. So that's where we'll use the product and quotient rule. But I distributed that 2 just because I'm following orders of operation. And really, since you've got different stuff on the numerator and denominator, order doesn't necessarily matter. There's plenty of different ways that you can do it. This is just how I would do it. So if we multiply on the bottom, just to simplify it just a little bit before we use that quotient rule, we can go ahead and multiply. So that negative times negative makes it positive, x. And then I've got same base y squared times y to the 4th, same base, add exponents. So then what happens is when we subtract this y to the 6th, you get y to the 0 if we're following those rules, and y to the 0 just is 1. So anything to the 0th power is 1. You could also think about it anytime you divide anything by itself, it's just 1. And then if we look at these x's, x to the 8th divided by x, same base, subtract, and leave it on the bigger, where the bigger exponent is. So 8 minus 1 is 7, and then negative 2 squared would be a positive 4. So I wrote that backwards somehow for some reason, I don't know. So, all right, last law is the negative exponents. And obviously, when I'm giving you the definition for the rules, I'm not using correct mathematical terminology, but I think it's easier to learn and categorize in your brain that way. So we're going to, with the negative exponent rule, we're just going to move to other side of the fraction bar. And so we've only got one example for this one, but it combines all of our laws up until this point. And so we've got 6x squared y to the negative 4th divided by 2x to the negative 3y squared, and all of that is raised to the negative 2 power. And so since it's all, the numerator and the denominator is raised to that negative 2 power, we have to distribute this negative 2 power into everything on the top and on the bottom. And so we've got 6 to the negative 2, x to the negative 4, y to the positive 8, all over 2 to the negative 2, x to the positive 6, and y to the negative 4. So we've got a couple of negative exponents in there. I think it's easier if we keep simplifying as we go. So before we do that, I know that 6 to the negative 2, well, no, we're not going to do that yet. Sorry, got too excited. So we're going to go ahead and move all of our negative exponents. So we're going to move the 6 to the negative 2 to the bottom. So now it's 6 positive 6 squared on the bottom. We'll go ahead and move that 2 squared to the top. This x to the negative 4 will move to the bottom. Keep that x to the 6th. Keep the y to the 8th up top. And then we're going to move this y to the negative 4th to the top. Now we're ready. So we'll simplify this 2 squared. It's 4. 6 squared is 36. 4 over 36 reduces to 1/9. And then we'll just use our product rule. So same base, add exponents. Y to the 8th, y to the 4th, y to the 12th. And then x to the 4th, x to the 6th, same base, add exponents, x to the 10th. So that's a really quick review of your exponent rules. I hope that was helpful.